Hi there. So today, as a special request from one of my viewers, I'm going to do a teardown of the air valve that I showed in the previous video. The other thing we're going to do is we're going to create something to give us feedback to know whether the valve is open or closed. So having a look at the motor, it's a TYC50 synchronous motor running off 12 volts, offering CW/CCW. I think that's to do with the direction, because I see some of these motors are single direction and other are dual direction. And the speed that it's traveling at is 0.9 revolutions per minute, and it's operating on less than 4 watts of electricity. So we've got the two wires from the motor coming up through this plastic shell, and those are coming directly to this little board over here. Now, I did try and look this board up on the internet using this number, but I couldn't find anything that told me exactly what this did. So if we look at this little board, it seems to have some sort of circuitry underneath this plastic coating over here. So I'm unable to see exactly what's going on there. But basically, we've got the two wires going out here on that side over there. We've got those two wires which are going directly to the motor. We've got a 24 or 12 volt something going on there. And then we've got the inputs, which is a plus and a minus. So from this, we've got the plus, which is going around here to the center terminal connection here, which is the plus that I'm connecting to. Then what we've got a little device over here that is going back and forth. And as it moves to the end of one of its travels, it presses this little button in over here. And when it moves over to the other side, it presses that little button in over there. So I'm assuming that these little button switches must be normally closed, so that when the button is in the out position, it is allowing the voltage to go through and move the motor. And the moment this little arm comes along and presses it down, that would basically cut the power off to the motor, and then it knows that it's reached its endpoint. Then once the power is supplied to the other side, it will be moving the motor back in the other direction until it reaches that switch, pushes that in, and it will stop the motor its gain on that side. So I did try and open the motor itself to have a look inside, but I think I would have ended up damaging it if I did that. So I went online and I managed to find a picture of what it looks inside. So you can see here that we've got quite a few reduction gears inside of here, which is giving you the torque on this motor, because it needs to be quite strong, because to move the valve inside there, it's quite stiff. So it definitely needs quite a lot of torque. So one of my viewers came up with a very good idea, because one of the limitations of this device is we have no feedback as to whether the valve is open or closed. So what he suggested is that we put a reed switch on the outside here and a magnet on the inside here, so that when the valve is closed, the reed switch will be closed and give us feedback. Now, I was a little bit unsure as to whether this would operate through the stainless steel casing of this device, but it works absolutely perfectly. So yeah, really good solution to be able to tell exactly whether the valve has closed or whether it is in the open position. Well, thank you so much for watching this video. I hope you've enjoyed this little teardown, and if you like this sort of thing, we might be able to do more of these teardowns in the future. If you've enjoyed this video, please like and subscribe, and I'll see you in the next one. Bye for now.